Hello everybody, welcome back. Another edition of Algebra 2. Today we're going to talk about complex numbers, and this is in section 4.4a, I'm calling it. And actually we're more specifically going to actually talk about just the imaginary numbers in this section, and then really in the second section we're going to talk more about complex numbers. Okay, so that's what we're looking at today. First of all, the objective for today, we want to be able to perform operations with pure imaginary numbers. So that's what I was saying again. We're just going to mainly be focusing on the just imaginary number part of it. All right, so first of all, what is a pure imaginary number? Basically, an imaginary number is a square root of a negative number. That's basically what it boils down to. Let me kind of walk you through this here. Okay, square root of 64. What does that mean? Well, we'd say, okay, well, the square root of 64 is 8, right? What does that mean? What that means is that if I took 8 and I multiplied it by itself, I would get 64, right? That's what that means. Okay, so in this case, yeah, square root of 64 is 8. Makes sense. But what happens now if you have the square root of a negative 64? Okay, well, obviously it's not 8, because 8 times 8 is 64, as we just saw here. And you think, well, okay, maybe it's negative 8. Negative 8 times negative 8, oh, wait a minute. Negative 8 times negative 8 is also 64, isn't it? So I think you can kind of see what the problem is here, that when we have the square root of a negative 64, there is no number that can be multiplied by itself to get negative 64, because to get negative 64, one number has to be negative and one has to be positive. So this doesn't work. So what happens is somebody along the line here came up with this. It's the imaginary unit, okay? So this is I. We use I, and what I stands for is the square root of a negative 1. Okay, so square root of a negative 1 is what I is. So basically what happens here, if we go back up to our negative 64, square root of negative 64 example here, I am going to think of this as being the square root of negative 1 times the square root of 64. So now if I split it up that way, and I say, okay, well now if I think of it as being negative 1 times 64, well, what's the square root of negative 1? Oh, the square root of negative 1 is I. So this part right here, we can just call that I, and then the square root of 64 is 8. So when I'm all done here, then the square root of negative 64, our answer would be 8I. That's how we would, using an imaginary number, we would use, we would find the answer to the square root of negative 64. So 8I would be our answer there. All right, let's look at a few examples here, kind of like what I just did. Square root of a negative 27. Well, how am I going to go about doing that? Well, remember, anytime you have a square root here and you've got a negative number inside, let's take out that square root of negative 1 first. So this will equal the square root of negative 1, and then we've got the 27, but maybe we can break the 27 down a little bit too. So think about what multiplies together to give you 27, where one of those numbers is a perfect square. And so if you can think of this here, you go, well, that would be like square root of 9 times the square root of 3, because 9 times 3 is 27. So what I've done is I've split this up as far as I can here, and then I go through and I say, well, what's square root of negative 1? That's I. That's my I. Square root of 9 is 3, and then the square root of 3, I can't do anything with that, so I just have to leave that. So basically, when all's said and done here, my answer would be 3I square root of 3. That would be the simplified form of square root of negative 27, 3I square root of 3. So we want to simplify everything that we possibly can, including the I and including any perfect squares, and then whatever else is left over is left over. Okay? You know, another way that you can think of this that you might have heard before is, you know, you just do the factor tree here, and you get this down to its prime factors, and when you have two factors that are the same, you know, if they have a date, then they can get out of the house. Okay, so you might have heard that before. And then here's another one, square root of a negative 125. Well, let's see what we can do here. Let's break this down into square root of negative 1. Now, 125, how can we split that up? Can you think of something there? How about this? Square root of 25 times square root of 5. 5 times 25 is 125, and the square root of 25 is a perfect square, so that's kind of nice. So square root of negative 1, that's I. Square root of 25 is 5, and then square root of 5, and so altogether 5I square root of 5. Okay? Handwriting's a little sloppy there. All right, a couple examples of simplifying those. Let's look at the next one. Okay, now here's the next thing to talk about. Different powers of I. Now remember what we were talking about here at the beginning. I is the same thing as square root of negative 1. But what's going to start happening as we start dealing with I a little bit, we're going to start getting some powers at times. And so it's kind of good to know what happens here. Think about this here. If I equals the square root of negative 1 and we want to find out what I squared is, basically what we're doing is we're saying, well, I have the square root of negative 1 and I square it. Well, what happens there? Basically what happens is this: the square root will cancel out the square. So those two things cancel out and basically just leave me with negative 1. So as you can see here, I squared equals negative 1. You know, it's the same thing if you don't quite understand that. Just think about something that's a little easier for us to understand. What if we had the square root of 4? Well, we know that the square root of 4 is 2, right? What if we then took that and squared it? What's 2 squared? What if we took 2 and squared it? We would get 4. So it's kind of like when we take the square root, it goes to 2, and then when we square it, it goes right back up to 4. So that's why whenever you see a square root and a square, those basically cancel each other out and leave you with whatever's left inside there. So that's why I squared equals a negative 1. That one's really important. We'll use that a lot. And then going further down the list here, I to the third. I to the third is really just made up of what? I times I squared. Well, what's I? Well, again, we said I is up here. What's I squared? I squared is negative 1. So this is really the same thing as I times a negative 1, which just equals negative I. Okay, as I've got written here. And then I to the fourth is 1. Well, what's that made up of? That's made up of I squared times I squared, and I squared is negative 1, so this is really the same thing as negative 1 times negative 1, which is positive 1. And then what happens after that? Once we get to, I think my light just died. Hopefully you can still see me well enough. Once we get to I to the fifth, this cycle just kind of turns back over again, and I to the fifth is made up of I to the fourth, which is 1, and I. And so I to the fifth is the same thing as I. And so we just kind of start back over. So let's take a look at a few things here. How would we simplify I to the 12th? Well, remember what I said before was that this is made up, or we can kind of split this up. Think about fours, groups of 4s. Because every time we have an I to the 4th, that really just equals 1, right? So I've got I to the 4th, I to the fourth and I to the fourth. 3 times 4 is 12, so that goes evenly. So if every I to the fourth is 1, that means it's 1 times 1 times 1, so I to the 12th would just equal 1. So if you divide this number by 4 and it goes evenly, your answer is just 1. What happens with this, I to the 17th? Well, what could that be made up of? You know, remember again, we're thinking in terms of 4. Well, we could split this up because it divides evenly at I to the 16th, because that'll divide out evenly and give me 1, like we just saw up here. But then I also have another, I got one more to make it 17. So this all just becomes 1 here, and so I end up with just I. I to the 17th could simplify to I. How about I to the 26th? Well, think about the biggest number that can be divided by 4 evenly. That's 24, because 24 divided by 6 will go evenly. So that becomes just 1, and that leaves me with I squared left over. And so this all becomes 1 over here, and I'm just left with I squared. Which, ooh, sorry, I should have gone one step further. I squared is really just -1. So that's what I should have left it at, not this. I'll just kind of scribble that out. So -1 would be where that should finish up. And then last one here, I to the 11th. I to the 11th, you go, well, what's the biggest one that can divide evenly by 4? Is I to the 8th. And so you have 8, 9, 10, 11. That leaves you with 3 left over. This all becomes 1, and we're left with I to the 3rd. Do you remember what I to the 3rd was? I to the 3rd was a negative I. And so that's how we would simplify that one. So there's some ways to simplify some bigger powers. All right, next, products. We're multiplying a few things, so we want to simplify this first of all. Two imaginary numbers, -3i and 2i. We're going to multiply them together. Okay, real simple. All you do is multiply the actual real number, like the -3 and the 2, and multiply the I part. Okay, so all we do here is we go -3 times 2 is -6. I times I, just like a variable, is I squared. But then we want to go one step further because we can kind of simplify that I squared there. I squared is really just what? -1. So this is the same thing as -6 times a -1, which just equals a +6. So that would simplify down to a +6. Okay? What if it looks like this? Basically on this, let's simplify these square roots here first before we multiply them out. You really have to take out this, make these i's here first. So square root of a -12 is going to be square root of a -1. And 12 will split up into what? Square root of 4, that's, and square root of 3. And that's our perfect square, the square root of 4. So this is really 2 and I. So we have 2i square root of 3. And then on this one, that's going to be square root of -1 again, times square root of 2. Square root of -1 is really just I. And so what can we multiply together here? We can multiply the i's, and we can multiply what's under the square root. So this is going to end up being 2i squared square root of 6. One more thing we can do, the I squared is really just a -1, so this will be -2 square root of 6 will be my final simplified answer there. Okay, so there's some multiplying with imaginary numbers. Last thing that we got to talk about is a couple examples with square root property. Okay, we're going to solve an equation. Here's another way that we can solve an equation using the square root property and doing some square root stuff here. take a look at this equation. What I'm going to do here to solve this equation using the square root property, I'm going to first of all try to get the y squared by itself. So that means let's get rid of this 20, minus 20. So I have 5y squared equals a negative 20, and divide by 5, just like we would have done before. So what I have now is I have y squared equals a negative 4. 20 divided by 5 is 4. So remember what we did before, where the square root and the squared to the second power cancel each other out? So to cancel out something squared, I take the square root of it. If I do it on that side, I have to do it on that side as well. So these cancel out and leave me with y, just a y. Whenever you're going through this process here and you take a square root on both sides to solve this, you have to account for both the positive and the negative, both the positive and the negative roots there. So you may or may not have seen this symbol before, but the plus or minus sign, whenever we do this step, it's plus or minus the square root of negative 4. But then we can simplify that a little bit. And so you say, well, what's the square root of negative 1? I. And the square root of 4 is 2. So this is really the same thing as plus or minus 2i would be our solution there. Okay? One more. 2x squared plus 50 equals 0. Let's get x squared by itself this time. So what am I going to do? Minus 50. 2x squared equals a negative 50. Divide by 2. So I have x squared equals a negative 25. Let's undo the squared. So we take the square root, take the square root. So I have x equals, remember, plus or minus, square root of negative 25. You know what that's going to be? Square root of negative 1 is I, square root of 25 is 5, so this will be plus or minus 5i. That would be our answer there. So that's another method that we can use to solve sometimes, not all the times, but in a situation like this, typically where we've got a squared term like a y squared or an x squared and a number, we don't have a trinomial. That's where we'd usually have to factor or perhaps use the what do you call it? Quadratic formula. So, but in this case, we could use the quadratic formula, which we will learn very soon. But this would be another way to solve this pretty easily. So, anyway, that's all we had to talk about on this section. In the second section in 4.4b, we will talk about complex numbers, where we have numbers that are made up of real numbers and imaginary numbers with an addition sign in between. So that's what we got to look forward to. So that's it for 4.4a. Thanks for being with me. I'll see you again in 4.4b. Bye.